Yeah, I was named after my grandfather, who was named after someone he was related to, who was named after Gov County, Kansas. Gov County is great. It's a tiny place. Like the whole county has, well, I don't know how many people live in the county, but the county seat is Gov, Kansas. It has fewer than 1,000 people that live there. It is a dry county. It is not legal to purchase alcohol in Gov County, so I approve of that. I think after I retire, I might go out to Gov County and offer to do some IT work for them, because they would qualify for the domain gov.gov. They could be gov.gov. And I would do some help for them. And in compensation, I would only ask for one thing, one email address that I could hold in perpetuity. And what would that be? gov@gov.gov. That would be a great email address. All right, but that's separate from today's content. So basically, we just got some data here that we can loop over. So let's go ahead and open up our Visual Basic environment. Alt F11 is the shortcut key that does that. And what do we have here? Looks like I've got another workbook open. Let me close that workbook. And it looks like we've got already a couple of modules here. So one is called Mod Web Query. Maybe we should just take a look at that one real quick. So I'm kind of giving this code to you. This is code that I wrote. You remember that we worked with, when we were learning how to record macros, we record ourselves making a web query. And we used the legacy web query because it records some very nice VBA, even though it's a little bit of a hassle to work with. So what these functions here do is they actually do that whole part of creating a web query without having to record yourself doing it. So you supply it a range where you want the web query to go. You give it a URL, some other optional things like whether you want to save the query or so forth. And then it will just build that query, put it where you want it, and give you the data. Like optionally getting rid of the query object itself, which is kind of nice. And then, what is this one? Oh, this one just builds a web query, like with whatever URL is in the active cell. And like something else, I don't even remember what these do. But anyway, so those are there, and they're like arguably kind of part of what we might use in this system that we're building today. Because the idea is that we've got, over here on our worksheet, we've got like all of these counties, and the government publishes lots of different statistical information about like these counties. And so am I saying, hey, I've got this list of counties, I want to get unemployment stats, or I want to get other stuff you might get from the census, like what percentage of the population is in like different ethnic categories and so forth. And so like the idea is we would say, go get the data for Alabama, the whole state of Alabama, then go get the data for just this county, then this county, then this county, then this county. We probably won't actually invoke this, like the web query to do that, just because it will really slow things down for us here. But at least this is like an example that you could say, oh yeah, here's kind of a full-blown working example that might be useful, a useful example of something that you might do. So kind of also then on module 1, we've got a couple of things. So one is right here, import county data. We give it the FIPS number as a string. And so this is kind of the first time I think that we're seeing what happens on the inside of these parentheses. What I've done here is I've declared a variable. Normally when we declare a variable, we declare it like just inside the subprocedure, dim s as a worksheet. Who can tell me something about this variable? Just say something about the variable. What can you tell me? Doesn't even have to be that interesting. Go ahead. It's an object variable. So, and it's a particular kind of object variable. It's only allowed to hook up to worksheets. So as an object variable, it just means it's going to hold the location in memory where some other object is. And so this is pretty similar to what we did last time we were together. We were creating a worksheet, right? So here we've got the worksheets collection. We're going to add a new element in that collection. It's going to go after, what's it going to go after? Someone kind of look at this clause and tell me where that worksheet's going to go. So this is referring to a worksheet. And because we're putting the after argument here, it's saying make this new worksheet and put it after whatever worksheet we're talking about here. Like, what's the English language way to say where that worksheet goes? I saw someone mouth it, but like my wife could read lips really well, but not me. So. Yeah, the end. Put this worksheet at the end. What does it say? It says, well, we're going to identify a particular worksheet. Which one is it? Well, here's the whole collection of worksheets, and we're going to refer to it by number. And the number we're giving it is however many worksheets there are. So put it after the very last worksheet. Put the worksheet at the end. That's what it says. So it's making a new worksheet, and then it's calling that create web query, and it's giving it the first cell on that newly created worksheet. So we create that worksheet, we capture a reference to that worksheet in the object variable. We're then going to say that worksheet that was just created, range A1, that is the range where we want you to put the data from this location. And importantly, this location has the FIPS variable. So when I declare a variable inside these parentheses, it really is a variable, and it declares just the same way that this one does, except you don't use the keyword dim. Why not? Because inside these parentheses, the only thing you can do is declare a variable. So you don't have to say, there's like no confusion about what's going on. You don't have to say, by the way, we're declaring a variable. No, that's it. That's the only thing you can do here. This becomes a special kind of variable called a parameter. And a parameter gets its value when we call the procedure. So if we look here, what it's saying is we're calling import county data. I think the first time we called the function, we might have said this, CALL. And if you do CALL, you have to put the argument you're sending in parentheses. But that is identical to just saying the name of the procedure by itself without saying call. So call is just kind of syntactic sugar to make old Fortran programmers comfortable coming over to VBA. How many of you are already comfortable in Fortran? None of you. So we don't need to learn that syntax. But that's the same way you would do it in Fortran. So this is how you call another procedure, just by putting the name of the procedure. And now, because import county data, this subprocedure says, hey, I've got a parameter here. I've got a variable that's declared here. It's expecting to get a value put into this variable when it runs. And so what we're saying here is, by the way, give this number 20063 to this variable. So when this is going to say, go run import county data is going to run, and FIPS, when it runs, is going to hold the value 20063. How comfortable are you with that idea of passing a value to a parameter? 0 to 5. 5, 5, 5, 3, 3.5, 3, 2. Okay, so this if you're a 5, you've done this in some other language. But here the idea is, all we're saying is, go run this procedure. By the way, this procedure has a variable declared here, which makes it a parameter. And we're saying we need to give a value for that, because the idea here is that whatever this variable is, when this thing runs, we want to know the value for that so we can do something with it. And what are we doing? We're embedding it into a URL to be able to get the data for that county. Oops. So that 2003 is going to get put right into this URL. And then we're going to say, go bring that data back, put it where we asked you to put it. Question? No? All right. So it was a little bit dangerous to run this code because I haven't run this now since last semester. And because it's a web server, like, am I in control of that web server? No. So whoever is in control of that web server could have changed it. This code may not work at all. But it's a government web server, so it probably isn't changing all that often. So I'm just going to see if I'm going to run this and see if it works. If it does work, great. We'll disable it because it'll be kind of too slow to run our examples with today. But it would just be nice to see if it actually works. If it doesn't work, we'll disable it anyway, but let's see what it did. So it looks like it ran okay. Yeah, it looks like it's brought some data in. So here's Gov County, Kansas. And what are we bringing in? I don't even know. This looks like some kind of labor statistics. Unemployment rate, labor force. Oh, I guess for the whole county, the labor force is 1,476 people in 2008 anyway, when the data is. I guess we could update this. Shall we update this? I don't know what we can put in here. We can probably put 2020 for sure. That's a census year. Let's put 2020. I run that again, run get data again. That should, we can kind of see the difference between 2008 and 2020. I'm guessing it will. Let's see if it did it. There's sheet 2. Hey, that's not bad. Looks like we went from We're going down. The labor force was 1,467. Now it's 1,459. We lost 8 people. It's my county, baby. All right. Now, of course, the whole point here is that, wow, we've got all of these. We just pulled, data for one of these counties. So we'd like to make a loop that does the same thing, but does it over and over again. So I'm going to come in here for get data, and let's start working with a loop. So let's bring the do loop in first. We've seen how to do something similar to this with the do loop, but we'll make it as a do loop. Then we'll kind of look at all the different variations for the do loop, and then we'll do the same thing with these other kinds of loops. So keyword do, keyword loop. That's an endless loop. We need some way to get out. So why don't we start ourselves? Let's dim a variable called row, dim row as a long integer. Why a long integer? So long is a data type for long integer. The range is, this is midterm stuff. If it was an integer, the range would be what? Plus or minus roughly, so byte is the one that's 0 to 255. That's an integer from 0 to 255. The next larger integer type is called integer. It is plus or minus roughly 32,000, about 32,000. And long is even a longer integer, roughly plus or minus 2 billion, about 2 billion. So what I'm saying is 32,000 is not enough. I got to go to possibly 2 billion. Why do I think 32,000 is not enough? How many counties are there? I don't know. Let's go look. Go to the end. There's only 3,274 counties. Could I get by with byte? Could I get by with byte? Would byte work for this? I'm going to use this variable to refer to each row individually. Could I use byte? You're saying no, why not? Yeah, as soon as I try to go to the 256th row, I'm doomed because it can't fit. I would get an overflow error. So, but could I get by with integer? Yeah, it goes 32,000, and this one's only going to 3,000. It's got like 10 times the capacity. That would be okay. And then the truth is, it would work just fine with long, with an integer here. Let me tell you why I prefer long. I prefer long simply because I'm saying, listen, I'm using this to refer to a row. I don't want to think about how big my data set is now or how big it might ever get. But I know if I use long, it's big enough, because how many rows can I have? 1.02 million, and long can take 2 billion. I'm never going to run out of space here. And what does it cost me to go from integer to long? It cost me 2 bytes. And I've got like 16 billion or 16. I've got a lot of these. I've already talked about it way too long, because the point was, for 2 bytes, I don't have to think about it. If I'm referring to a row, make it long and I'm done thinking. Okay, but integer would work for this particular problem. We'll start off at a particular place. Where do we want it to start? We probably want to start on row 2. So dim r, r equals 2. And now inside the loop, we want to do a couple of things here. There's something we have to do to be able to get myself referring to a different row all the time. So how am I going to do it? I got to increment r. What do? Put a new value, sorry, not r, it's row. Row your boat. I got to change row, and it's going to be what? Yeah, what it used to be, what it currently is, +1. I'm saying give me a new value to put in this location in memory. What is it going to be? Well, the first time I hit this, it's going to be 2, so that will evaluate to 2. I'll add 1 onto it, that'll make it 3, and I got a new value 3 in that variable. Now, I probably also want to use that to determine what I'm sending to import county data. Now, import county data is on this sheet over here. In fact, let me just go ahead and kind of shrink this down a bit. Okay. So this is on a sheet called counties. Now, if I look right here in my Project Explorer, and if your Project Explorer isn't showing, choose View, Project Explorer. That'll make it show. And now I can kind of look at these sheets. And right here is the county sheet. It has two names. Whoa, two names. The one in parentheses is what shows on the tab. The one not in parentheses, and by the way, the one in parentheses, the property name is name. The property name for this is the code name. Ooh, it's got a code name. It's not like it's a secret agent name. It's like the one you would use to refer to it in code. Like, so I could say, question mark active sheet, ACTIVE sheet dot name is counties, but it has another property called code name, which is county. This is how I could refer to that sheet directly through code. So what I'm going to say is, instead of just always sending down the number for Gov County, I'm going to send down that sheet. How do I refer to that sheet directly? County, that's the code name of the sheet, dot cells. Oh, I don't think we've talked about cells yet. Cells is coming up. Cells is a way I can refer to there are lots of things I can do with cells, and we'll see all the different variations. But I can refer to a particular cell by giving it two integers, a row number and a column number. And that's nice because my row is actually held here as an integer. So I can say I'm looking for the FIPS code, which is O is in column 1, but in whatever row we're after. So anytime I have an ordered pair referring to a cell, it's always row first and then column. So whatever row is, but column 1. And I don't want the font of that cell. I don't want the background color of that cell. I don't want to know like the formula. I want the value of that cell. So this is saying, great, we are going to send down, the first time through, row is going to be 2. We're going to send down FIPS number 0100. And that is then going to be received into this, ultimately put into this URL, and that will be what gets our data. Ah, wonderful. Now, that looks good. What else should I do anytime I've got a do loop? There's kind of two other things, one I have to do, and one is a good recommendation. Can you come up with either one of those things that I've got to do next before I run this code? Go ahead. Ah, so you're saying inside this loop, put do events. Do events just says, this loop is going to get serious about doing this as fast as it can. And we want to say, hey, like one time, every time you go through this loop, at this point, just poke your head up for a millisecond and say, does anybody want to get my attention for anything? No, okay, I'm going to go back and get back to work. And so if I'm doing something that's updating the screen, then that do events will give a chance for that screen updating to happen. But the reason I'm doing it is that just in case this accidentally goes into an endless loop, I want to be able to get out of this thing. And if there's a do events in there, by clicking the pause button, it will let me interrupt the code. So that's just to keep me from accidentally putting myself into an endless loop, which is what I have done. So what's the other thing I have to do? I got to give some way out for this. Okay, so far, everything we've seen has been the same. So I'm going to do this the same way that we've done before. I'm going to say do, put an until clause here, until, and I just want to kind of look at this value that I'm getting ready to send down. I want this to run as long as there's something there. So I'm going to do until that value is equal to a 0-length string. There's another way for me to do that. There's another way for me to say, that thing is empty. There's actually a function built into VBA called isEmpty. I thought it was empty, or is it just empty? Do UN? Oh, this is my error here. There we go, isEmpty. And so isEmpty is a function. I pass it some expression, it returns true if whatever I sent it was empty. Otherwise, it returns false. So EMPTY, I'm going to pass it a string with something in it. That's going to say false. That's not empty. How about an empty string is empty? That's also false. But if I give it a cell that's empty, active cell dot value, right now that's false because my active cell has something in it. But if I come over here and run it, it'll tell me true. Oh yeah, that's empty. So that's a way to look at a cell and have it tell me if it's empty. Putting it, asking until it's equal to a 0-length string, its value is equal to a 0-length string, that would work as well. Yeah, I should specify the value. Questions? Just kind of another way to tell if something's empty, and kind of looks a little more professional if you say is empty instead of equals a zero-length string. I don't know. Now, until is not my only option here. So until is going to execute until this is true. I can also execute while something is true. So like this is exactly the opposite. This is going to do while this condition is true. So how many times is this line going to execute when I execute this code? If I was to run this code, in fact, I will with F8. Let me just do it. I'm going to press F8 to run this thing. I get right here. Or so we're going to evaluate this right now. Am I going into this loop or am I not going into this loop? I'm not going into that loop because it does it while this condition is true. And that condition right now is false because row is 2. We're looking at 1. We're looking at that cell right there. And it's not empty. If so, is empty is false. This works while this is true. It's false. We're done. We never jumped into that code. Watch this. Here's another variation. I'm going to stop my code. And I'm just going to bring this whole clause to the end. So I can put my exit clause either at the beginning of the loop or at the end of the loop. So now, has it changed what this is going to evaluate as? Am I going to come into this loop? Let's take a look. F8 to run step at a time. Because the exit condition is way down here, it doesn't even check before it comes into the loop. It's going to come right into here. It's going to execute that line. I don't want to wait for that to execute, so I'm just going to skip over it. It's going to come to here, and now it's going to check the condition. It's never even checked that condition until we get here. Now, row has gone up by 1. Row is now 3, so it's going to be looking at this cell right here. And while is empty, while this is true, is this true or false? That's false. Is empty is false. There is something in row number 3, column 1, and so that's going to let me out. So kind of interesting here. The condition was, oh, it was false. That condition, it's looking at a different cell when we get there, but last time we looked at it was false, we didn't enter the loop. This time we look at it's false, but we did go through the loop, and that's the effect of putting the exit condition at the end. The only difference is that if it's at the front, it will check before you get into the loop. You put it at the end, you're guaranteed to run the code in the loop once and then check it. You might think, oh, this is going to run one more time. No, the only difference is, will it run the first time? Because by the second time, nothing happens between the do and the loop, right? I've come through here. I've checked to here to see if I would exit. Otherwise, the next thing is go up here and then check here. Like nothing happens between those two. So this doesn't say run it one more time. This just says be sure you run it once first before you look. So you can use while or until, and you can put that at the top or at the bottom. I'm going to turn this back to while to until, so it'll actually execute. UNTIL. And then I'm going to come down here, and instead of actually going and getting this data, I am going to just print FIPS. So debug.print FIPS. And so I'm actually going to go ahead and run this, and we'll see that that will print off all 3,000 of those. In fact, even that will take longer than I want it to do, but let's go ahead and do it. Run that. I'll run it again. And do until. I kind of expected that to run more than just once. Oh, stop. Oh, no. Fortunately, I have to do events in there. So I'll press my pause a few times, and it should exit kind of when it's done getting the current data that it's working on. I dearly hope it will. There we go. Ooh, what I meant to say was not print it and then go get it, print it and then don't get it. So I'm just going to put here exit sub. So exit sub just says, whatever is below here, we don't care. Get us out of here. Go ahead. Oh, does is empty have to have a value as an input? You're saying, can I just look at the cell? It will work just fine to say is empty the cell. But the reason this works is because if I don't say the property I want, VBA is going to default to the value property. So it really is looking at a value. It's not looking at a cell. It's looking at a value. And it just happens that it would work the same that way even with it. I'm about 92% sure what I just said was true. So, but yeah, I mean, it's possible that it does actually look at the object when it's passed the bare object, but I don't think so. I think it's automatically getting the default property. Okay. So yeah, now I should be able to, now that I've got that exit in there, I'm going to save. I probably should have saved before I even ran the loop, but I'm going to save that. And then I'm going to go ahead and run this, just hit play to keep running. That's an important thing to realize, that when I'm in break mode with this yellow line here, if I hit play, it'll just kind of keep going from where I left off. And it'll go through and print all of those FIPS numbers. There's 3,000 some odd. They're not, you'll notice they're only odd. We've got just odd numbers, and they have other gaps in the range as well. Okay. One more thing to learn about the do loop, and this is true of all loops. Just like I can exit a sub procedure to get out of that sub procedure kind of ahead of schedule, I can do the same thing with a loop. So I'm going to come in here and say exit do. So here's exit sub. I'm executing a sub procedure. Here's exit do. I'm exiting a do loop. So in this case, we're going to come down here and we're going to get to here, and this is going to take us right out. So this will now only run one time. I mean, it's only going to iterate once because this exit do takes us out. And even though we haven't learned the if statement yet, I'm just going to kind of tease us with it right here. I'm going to say if row is greater than 100, then exit do. We'll have a whole day where we talk about conditional branching with what we're doing here. But this is going to say just, hey, if this is true, go ahead and execute this statement. Otherwise, don't execute it. So now it should run the first 100 values. So that's about all there is to the do loop. So you can look to exit either at the top or the bottom. You can use either until or while, and you can use the exit do to get out. Even, that's something more complex, because what I might say, do exactly what I've done here. Yeah, let's look through all the data. I quit when we hit the end of the data, but maybe I'm looking for something in particular. So keep looping until I find it. And once I find it, do something different, and then I'm done with the loop. So that's the idea of exiting, a kind of another way out that might have some more complex conditions. And yeah, and we'll see some examples like later in class why you go, oh yeah, it makes sense to have both an exit condition and to have some other, you've noticed some other condition saying, yep, I better stop now. Better stop a little ahead of schedule. All right, so that's get data. I'm going to make a copy of that. I'm going to leave that one the way it is, and I'll copy it. And we'll call this one get data. I'll call it for. This will be a different kind of loop, the for loop. So it turns out that what we've done here with the do loop, saying I want to take a variable across a range and do something for every number that's in that range, that's something that we do so often in programming. They wrote a special kind of loop just for it, and it's called the for loop. So the syntax is different. Here's what I don't do. I don't give it the value. I don't give an initial value to the variable. I'm going to get rid of this. And instead of using do, I use for. And instead of using loop, I use next. So, and there's no exit condition over here. So, so the do loop, the keywords are do at the top, loop at the bottom. The for loop, the keywords are for at the top, next at the bottom. Now, in my for loop, I said you don't give an initial value, but you do. You just do it here. You don't do it before you get to the loop. We're saying, oh, this is a for loop. Great. You're going to have some integer variable that you're going to be working with. Great. It's called row. And here you give it the initial value. So this is a for loop, and I'm giving my variable at a starting value. This variable starts at 1, and this really does assign 1 into the variable r. I then tell it how far I want to go. To, why don't we say 1,000? I'm going to comment out this exit. I can't exit the do here because I'm not in a do. That'd be a problem. So now what we're saying is, we know the range we want to iterate across. It's going to start at 1. This is actually going to put the value. What is in R before we get here? It turns out 0. Every numeric variable when you declare it, it starts off with a 0. That's not true of all programming languages. If you declare a variable in C++, if you declare like an integer variable in C++, what's its initial value? This is weird. So remember that, like, if I'm declaring an integer, it takes 2 bytes of memory, and the operating systems, I say, hey, operating system, give me a variable. And the operating system, I say, the interpreter says, operating system, give me 2 bytes of RAM. The operating system says, here's 2 bytes of RAM that no one's using. I'm going to allocate it to you. What's in that already? What is sitting there? Whatever was there from the last time it was used, a bunch of ones and zeros. There are 16 ones and zeros in that 2 bytes of RAM. And what is it? Whatever was there before. Like, it might have been a part of a picture. Some ones and zeros representing a part of a picture. Well, those ones and zeros, now that we've said, hey, that's an integer variable, those ones and zeros mean some number. So like in other programming languages, C++, for example, when you declare a variable, you get the memory, and what number is in it? What number might coincidentally happen to be there because of what was already that memory was last used for. And that can, if you don't initialize your variables, if you don't actually say in C++, I've got this variable and it's going to start at something, then you have no idea what it's starting at. In VBA, remember, they're trying to make a language that's really user-friendly, so they say, listen, you don't have to initialize your variables. We'll initialize them for you. Every numeric variable starts at 0. You don't have to worry about it. But what I'm trying to point out here is it doesn't matter what it was before. I could come in here and say, you know what, row equals, I often wonder why they put the 0 key and the O key right next to each other. They are right next to each other. Row equals 300. And that would have no effect on this loop. Why? Because the first thing this loop does is it sets row equal to 1. I'm not going to do that because it doesn't make sense, but the point is, it doesn't matter what row was before, it's going to go to 1. So now let's do this. Let me go ahead and right before I call this, I'm going to print row. Let me put a comma after it. The comma after it will suppress the carriage return that it normally wants to print. So it should print row, and then it should come down here, make the call to import county data, and print the FIPS, the FIPS number. Okay, there was a question here in the front.
Should row actually equal 2 so that it's on A2?
Oh, excellent. Yeah, that's excellent. Very good. So this is just me thinking that normally when I create a loop like this, I start at 1, but you're right. It shouldn't start at 1. It should start at 2. Thank you. You saved me the embarrassment of sending bad data to my procedure. Right? Because I would try to be asking for a FIPS code that was FIPS code. There's no FIPS code that's FIPS code. They all start with a number. They're all a number. Okay, good. So now I should run this, and this should print 2. The comma will put a tab there and suppress the carriage return, which will allow us to see the FIPS number that's printing down here. So yeah, so it's going to start. Well, I better do to 100 because I only have 200 lines in my immediate window, and then they kind of scroll off into oblivion. And so this should let us see all the results. Go ahead and run that to 100. There we go. So I can scroll up to the top. The very first one it ran was 2, and that was FIPS number 1000. That's FIPS number 1000. And it kind of goes through and does the rest of them. And so with the do loop that we had here, every time through that loop, we're checking to see, are we done? We get to the loop, are we done? We get to the end of the loop, are we done? Are we done? Are we done? In this case, we're saying we know going into this loop how many times we have to iterate. And so at the end of this loop, it just checks, it says, is 2 100 yet? We get to next, it goes, is 2 100? Is 2 100? Actually, it doesn't go if it's 100. If it's 100, it's legal, right? Does it actually execute when X is 100? Yeah, it printed out X of 100. And so, in fact, let me do this. Let me put a stop here, which will run to that point. Get data 4. And now I'm just going to come up here. So this has me stopped. So X is still sitting in memory with its value. What do you think X value is right now? Not X, it's row. What's that?
The
I did mean row, yeah. I did not expect 102. I expected 101. Go ahead.
The rows will go
Oh,
by two.
yes, it's because of, that's right, because of this. This is left over from what? This is left over from my do loop. In my do loop, I had to increment row. Yeah, I didn't even notice that, right? This is counting by twos, 82, 84, 86. So I have, in a do loop, if I'm trying to increment a variable, I have to do that itself. But in a for loop, the next statement automatically increments the variable. Let's run that again, and we'll see that it is running everything. So now my X is 59, 60, 61, 62. It's still going up even without the statement that's incrementing X, because the whole nature of a for loop is to move a variable across a range. And if I don't tell it how much to increment by, it will increment by 1. But I can tell it to increment by a different number. Maybe I do want it to count by 2. Simple. Step 2. The step clause here tells it how many to add at the end of each loop. And if I don't include that, the default is to step by 1. Or increase by 1 every time. Actually, I haven't run that with the step 2, but I'm stopped right here. So I'm just going to take a look at what row is. So right now, row is 101, because the reason this loop ends is because the control variable, in this case row, goes out of bounds. It actually goes beyond the limits we specified for it. And then that's what lets us out. So it seems a little strange. You might think that at the end of this loop, the control variable would be the top value, but it's actually the top value plus the step. So now that I've changed that to step of 2, now when I look at row at the end, we'll see it is 102, because it was 100, it added 2 to it, and then it let out. Questions? Turns out we can make this thing count backwards as well. So instead of going from 2 to 100, I can go from 100 to 2. In that case, I got to add on a negative number. And so this should do something really similar, except it'll go backwards. So here's the first thing I printed out. X is 100, and that's going to be whatever value still is on row 100, and it's subtracting 1 off every time. Again, we're out of bounds here, so we've come out of bounds. So what do we think row is going to be if we look at it now? Any guesses? Yeah, should be. We say it to be 1. Because our step is -1, it's taking 1 off each time, and it's now outside the legal boundary, and so that'll take us down. It's not true to say it's outside the legal boundary. It's saying it's below, like it's on the wrong side of this number to say it. Like if we did something to X to make it go larger than 100 inside this loop, that would not take us out of the loop. So it's when it gets smaller. If it's a negative number here, it's when it gets smaller than this number. If it's a positive number, it's when it gets bigger than that number. Okay. Anything else on the for loop? Yeah. Let's put this back to 1,000. And now let's say, hey, if X, and let's count up instead of down. Let's start at 2 and go to 1,000. Now we're going to re-invoke our early exit clause. What do you think I have to change on this? If you're just guessing, what would you change? Instead of do, put 4. What? 4? So now, even though this is trying to get bigger than 100, as soon as we hit to 101, this should let us out. We'll run that, prints to 101, and we're done. Oh yeah, it's because it actually went to 101. So what do you think X is now? Is X 101 or is it 102? If only we had a way to look. Not X, row. It's 101. Because this is what is incrementing X. This is what is incrementing row, and we never hit it, right? When we said if it's greater than 100, Get us out of here. We skipped that line. So in that case, it does end with that top value. That's it for the for statement. Any questions on for? Like all the complexity I know about for. And yet we're not done. So let's make another copy. And I'm going to call this get data for each. For each. So you remember that we invented the for loop because we said, wow, like this thing that we do is so common. Iterating, taking a variable and moving it across a range and doing something for every value in that range. Like we do that all the time. Let's make a loop specially for it. Could we have gotten by with a do loop? Well, technically no, because the do loop is actually newer than the for loop. But I mean, if they were making the language from scratch, we don't need the for loop. You could do it with a do loop. But it's convenient, so we're going to use it. There's another thing that we do all the time. It's another like pattern that we do all the time. So one of them is iterate, take a variable, move it across a range, do something for every value in that range. Another one is I want to do something the same for every object in this collection. So I could write a loop. There's a loop specifically made to say I want to loop across all of the sheets in this workbook. Let's write that one first, and then with the for each loop, and then we're going to modify this same example to use the for each. Oh, there's one thing I wanted to do on the for loop first, and that is instead of like having this part hard coded, I want to calculate where it should end. With the do loop, we're saying I don't know, like the next data set we get in here might have new counties, like they might make some new counties. When was the last time we got a new county made in the United States? I don't think it's happened in my lifetime, but you never know. We might get a new county. Or maybe I might combine some. Gov County, if Gov County keeps shrinking, they might combine it with the next county over. I don't know. And so what we're saying is maybe we should use the do loop because we don't know how long the data is going to be. In this case, for the for loop, we're saying you know how long the data is going to be, but you don't have to know like forever. You just have to say by the time this loop starts, we need to know. So another thing I could do is I could start by figuring out what is the last one. So instead of having this be like an expression that can't change, let me make another variable. Dim last row. As long. It's a row, so I don't want to think about what can it be. I'll just make it the maximum that it could be, as long. And now I'm going to say last row equals, I don't think we've seen what I'm about to show you yet. We're going to talk about it in great detail coming up. So at this point, just kind of look at it and believe. I'm asking you to have a little active faith with me here today. I'm going to say my county's sheet, C-O-U-C-C-O-U-N-T-Y. What did I just do? C-O-U-N-T-Y. So I'm going to look at this sheet. On that, I'm going to look at a particular set of cells. By the way, cells is like the whole, is all, this refers to all of the cells. If I don't say anything else, this is every cell in the workbook. That's a lot because it's like 16,000 times 1.04 million. It's a pretty big number. But I'm going to say, no, I want a particular row and column. This would be the very first one. Well, I want the first row, but I want the very last column on this worksheet. Well, I can ask county.cells.count because cells is a collection. It has a count property. Not county.cells.count, county.rows.count. That tells me how many rows there are in the sheet. How many are there? 1.04 million. I don't really want to go all the way to there. Like if I was at the very end of this worksheet and I wanted to come up to where the data was, what would I do? How would I easily get up to where the data is in this column? What keystroke would I press? Control up arrow. Yeah. Actually, before they invented the control key, we used to do it with a 2 keystroke sequence. We hit the end key. I don't know if you have an end on your keyboard. I tap the end key. I'll do it one finger at a time. Are you ready? End, boop, up, boop. Does the same thing. So why did I tell you about the end key? Because instead of doing rows.count, yeah, this is going to this will refer to the very last cell. From there, I want to run the end method and tell it to go up. XL up is a constant, I can just run that and it will tell me that is a name for this negative 4162. And that just means that the code, you tell it to move in the up direction. And this now will refer to the last row that holds data. It'll refer to the first cell in the last row that holds data. And I want to know the row number. So I'll say dot row. Whew. At this point, if you're like, wow, I don't understand that whole line, that's okay. Look at it and say, that's magic. And just type it in. Or just watch. I'm missing the what? Oh, yeah, it's probably hard for you to see. Let me darken it in for you. There, I'll darken that one. Yeah, you're kind of sitting far back there. Thank you. All right, so now let me run that to there. Debug county.cells row. Oh, the row comes first. Row, that row, column 1. So now if I look at what last row is, it darn well better be 3274. Last row. So now that I've figured out what the last row of data is, like this doesn't have to only go to a literal, I can tell it, I can figure out where it has to end and then tell it to go to where it ends. And then that will execute the same way. It'll still end after 100 because of this loop, but I guess we'll go ahead and run it. So it still like figures that out. So the point that I wanted to make sure you understood is that that doesn't have to be numeric. It can be any expression that evaluates to an integer. All right. Show me how comfortable you are with this statement. Would not expect a bunch of 5s here, but 4, 5. Okay, so you're not too bad with it. Okay, great. Well, we'll skip that part when we get to it then next week. I'm just kidding. We'll still talk about it. Okay. Okay, so now let's look at the for each loop. But I want to do another for each. So dim for each sheet. Okay, so just like the for loop, I do need a control variable. So let me dim S as a worksheet. So the for loop, I got to have numeric, maybe even integer. I'm not sure it has to be an integer. I think you can only step by an integer, but I'm not sure if it actually has to be an integer, but you always make it an integer. But this, it needs to be an object variable because what we're going to do is we're going to define some collection, and then we're going to tell this to automatically iterate over the collection. And so the collection that I want to iterate over is worksheets. Right, so that's all the worksheets in the current workbook. I can specify the active workbook or this workbook. I'll go ahead and specify this workbook. This workbook.worksheets, that refers to the collection of all the sheets in the current workbook. So now for each goes like this. For each S in this collection. Next. In the for loop, we take this control variable and we're changing the number that's in it. In the for each loop, we're going to bind this variable onto a different member of this collection each time. The first time through this loop, S is going to point at the first sheet in this collection. The next time through the loop, S is going to be referring to the second sheet, then the third sheet, and we'll do that for all the sheets. And so in here, I can just say debug.print s.name. And you think, wow, that's going to print something different. Like S's name is going to change each time? Yes, because the S object variable is going to be pointing at a different worksheet every time. Counties first, then sheet 1, then sheet 2, then sheet 3. If I run that, that should just print off the names of the sheets. Counties 1, 2, 3, 4, 5, 6, what I have. So this is a little bit more abstract because it's not just changing a number, but it's changing what this object variable is referring to. Show me how comfortable you are with that one, 0 to 5. Yeah, I'm seeing some 3s out there, which is what I expect. This is a little bit more abstract. we're going to do lots of examples with this loop throughout the class, so you'll get more familiar with it. In fact, we'll do another one right now. So I'm going to come down here to my get data for each, and let's now change this. We're going to do the same thing, but instead of taking this number across a range of values, I'm going to refer to a different cell each time. So instead of row, I'm going to dim range, RNG, I'll dim cell, CELL, as a range. So again, it's an object variable. It's just going to be enough memory to point at a different thing in memory each time. And now what I have to do is I have to give it the collection of cells that I want to go across. So for each cell in, and it almost seems like cell must be a reserved word because I'm going to refer to each cell in a range, but this is just a variable name. Could call it anything. For each cell, and now I got to give it identify some collection of cells that I want to iterate across. Again, this is kind of more than, this is other stuff that we haven't really learned yet. Let's do this one. I don't think we're otherwise going to see this one in class. I think, yeah, intersect is right. Okay. So let's just kind of take a peek at a couple of ranges. So columns 1. So this is a way to refer to a particular collection of cells. So this is going to be a range, and I'm going to ask for the address. And so that's telling me the address of that range is A:A. That is the whole of column A. So that's one that's interesting. Let me look at another one that's interesting, and that is the used range. Dot address. Another way to look at a range. USEV range. Maybe I have to identify the sheet. Active sheet dot used range. There. So the active sheet's used range is the smallest rectangle that bounds all of the data on the worksheet. So it starts in A1 is the first bit of data, and it ends in column C, row 3274. So that is the range, that's the smallest range that holds all the data in the sheet. If there was no data on the first row, it would start on B. So it shrinks down to across all that data. So interestingly then, I can use the combination of those two to give us like the intersection between those two. So let me come down here, INTERSECT. So the intersection of that particular one, that particular range, and this particular range. And we want to print the address. Active sheet address, intersect. Active sheet.used range. Oh, not address. I don't want the address on these. They actually be the references to the ranges themselves. And so now that gives me what is both the cells that are in both of those collections. What's in A1 intersected with what the used range is. And interestingly, if I want to, I can offset that because I don't want to start in A. I want to offset that by 1. So I want to start in B is where I want to start. Row, oh no, I don't want to start in B. I want to start it in row 2. That's right. Still start in column A, but start in row 2. So this here is the collection of the cells I'm interested in. Actually, it's got one more at the end, but we've made it complex enough. So the point is that this expression gives me a particular collection of cells. So now I can iterate this object variable across that collection. So now the first time through this loop, this cell variable is going to be pointing at which cell? The first time through this loop, this variable will point at the first cell in whatever collection I identify here, just like this variable pointed at the first sheet in this collection now we're pointing at the first range in this collection of range, the first cell in that collection of cells. So if I was to come here and say debug.print not row, but cell.address, what would it print? Take a guess. It won't hurt if you get it wrong. Here, when I printed the address of that range, that's the address. So what's the first cell in that range? A2. So the first time through this loop, this object variable will be referring to the first cell in this range, which is A2. The next time through, it will refer to A3, then A4, then A5. And so I'm going to print off the address, and then I'm going to call import county data. And the value I'm sending it is, what do I put here? I'm going to replace this with what? Cell. Like cell is now an object that's going to refer to each element in this collection one at a time. The first time through, cell refers to A2. I want to send the value that's in A2. The next time through, A3. The next time through, A4. So this should now print the address of the cell and then print the FIPS number that's in that cell. Let's see. Let's make sure we're getting out of here. So let's say if cell.row, if the row of the cell is greater than 100, we're going to get out. I'm not doing anything else with row here, so that looks like that'll be okay. Debug.print address. So now instead of printing the row number, we're printing the whole address. We're still printing the FIPS code that goes along with it. You use the same keyword to get out of a for loop as you do out of a for each loop. So these are like the three main loops that we're going to use in VBA. There's some other, like even older style language that, you know, goes back to the 1970s, the early days of basics. There are some other loops. There's a loop called the while loop. Starts with the keyword while, ends with the keyword. I don't know why you would know this. Anyone know? Like wend, W-E-N-D, like the end of the while. While at the top, wend at the bottom. But that's been really replaced. It's still valid syntax, but it's been replaced with the do loop. Do loop's more powerful and more general. There may be even other loops that I don't even know about. Oh. Okay, show me how comfortable you are with a for each loop. If I see a bunch of fives, I'll know you're lying. So 5, 4, 3, 2, 1, 0. Is it 0? No, okay. So yeah, this one's, the for each loop is the most, it's the most abstract. There's a lot going on kind of under the hood. And if you're looking at it going, whoa, this blows my mind, that's all right. We will get familiar with it as we go. All right. Well, let's also then, since we've got some time here, let's go ahead and re-enable our ability to pull data in. So instead of exiting down here, let's actually bring the data in. Actually, let's do this. I'm going to get rid of the exit sub. And all this is doing is it's going to bring in a sheet. And I know that it's going to be the active sheet because it will have been the most newly created sheet. So when this runs, that new sheet will be the created one. And so what I'd like to do is I would like to actually use some loops to bring that data in. I actually want to bring the data off the sheet. In fact, maybe what we'll do here is, maybe this is what we'll do. Instead of actually bringing it in, because that'll just kind of, we'll have to wait for it. Let me undo this back to exit. So here's one of the sheets that's been brought in. I'm just going to make this the active sheet. So we'll run this code. Now, it's kind of interesting to notice that there's nothing about this that says make the sheet active, right? This sheet that I'm iterating across does not have to be the active sheet. So if I was to run this with F8, here's for each. So this, we're going to print this stuff up here. It's going to work just fine without, even though it's not the active sheet at all. because we haven't done anything that says refer to the active sheet. So this one's still active. So the idea here is that we're going to let the get data one down here, make that become the active sheet. And we'll just kind of simulate it by like having this sheet active to start with. And now let's go ahead and bring that data in. So what do we have to do? What I'm after is I want to bring in, like, let's say I'm after the labor force data. That's what I want to bring in, labor force. I've got to come across this range here. And we've got like the year and the month. And we now want to put that going in here. Like when I bring in Alabama, I want to put that data right through here. So this is going to be like, I'm trying to get this workforce data. So why don't I start off by, let's just go ahead and make a simple loop that just puts the names right in here. So we're going to read across. We'll have something separate because we only have to put this in once. And let's read across this and put the right information in there. So maybe even before we get to this part. Yeah, let's just make another function that does this, another subprocedure. So I'll make a subprocedure here that's called get headers. And get headers is just going to read the data on the active sheet, and it's going to put it in the right place of the county's sheet. So why don't let's go ahead and let's go ahead. What loop do you want to do? So we got to go across all of this. There's like 199. Oh, preliminary. Yeah, I guess we'll take the preliminary data to OP. I think that's like a footnote. For simplicity's sake, I'm going to delete that footnote off so we don't have to deal with that, even though it's saying that this is just estimates at this point. I guess that makes sense. We're saying, hey, we're not really sure about November yet. After all, that was a couple of months. It's only been a couple of months since we got that data. What loop should we do? We've got to go through, we're saying we don't know what data is coming back. Just take whatever we have here in column A and B, and we'll use it to put the headers across for our data table. 3 choices. Which one do you want to do? I'm glad to do any one. Which one do you want to do? You want to do the hardest one. Okay, we'll do 4 each. If someone wanted to do the easiest one, you'll have to speak up sooner next time. All right. So, curse you, Perry the Platypus. All right, let's go ahead and, so we'll need a dim cells, or dim cell as a range object. For each, let me put a little comment here what we're doing. Reads data on the active sheet and writes the headers. Okay, so now we gotta have an expression that figures out that, I'm just gonna copy this for each line here. For each cell in, I think we still want the intersection. I think that's still what we want. So I'm just gonna, we don't want to iterate for every cell in both of those columns because that would have us going, run the loop once for A2, then B2, then A3, then C3. So I still want to go this loop just to go once for each row. Next, and let's just print those off and make sure this is always a good idea, NEXT. It's always a good idea to say, let me just make sure I understand the loop. So here, let me print off the address of cell and make sure that this makes sense. So debug.print cell.address. So I'll run get headers, and what I'm expecting that to print is A2. I want to start at A8. So let me offset that by 7 instead of 1. So this should start at A8 and end at A198. So we're running get headers. And it went to 199. Oh, and it's probably because this is probably still part of the used range. even though I've deleted the data that's off that. So I'm just going to delete these rows here. Actually delete the rows, and I'll run that again. Still ending in 199. Oh, it's because I've offset. I offset 7. Seemed like it would have done more than that. But let's see what it's doing. It's bringing in, starting at a, starting at A2. Oh, I offset the wrong one. Thanks. This is the one I wanted to offset. Offset 7. Yeah, this should have been 1. Thank you very much. So yeah, that's going to start now at A8, and it's going to end off 8 rows below. It's going to be more complicated for us to, get rid of those extra cells. I don't want to add that complexity in here. So we'll run this again. It should start at A8, and we should be ready to go.
Russell,
Yes.
did you mean to delete the data?
Not really.
No, from Excel.
Oh yeah, totally not. Thank you. Okay, so now we're starting in A8 and we're going right down column A. So as much as I wanted to flex by doing what you chose, this is going to make it way more complex than it should be. So we're going to go to the 4, we're going to go to the 4 next one. So dim row as a long integer for row equals 8, 2, and just because we're getting out of time, instead of calculating it, I'm just going to go to 198. Like we could have another expression that figures that out. Let's just go to 198. And I'm going to print, I'm just going to print row, and I should see 8 to 190. As log. Log is not actually a data type. Bug.print row. Okay, so now we've got 8. We've got 8 to 198. Okay. So now what I want to do is I want to look at those values. Maybe I'll just print those values off. So I'm going to print off, I'm going to combine them together when I print them off here. So I'm going to look at cells. If I don't tell it what worksheet, it'll assume the active sheet. And that's what this does. It looks at the active sheet. Cells row number row, column number 1, dot value. And then I want to add, I think I actually want to add column. I want to add column 2. Whoops, concatenate column 2 with a space, and then what's in column 1. So this, because I want to say April 2021, May 2021. That's what I want to actually show. Okay, so now if I look at 198, that should be November 2023. November 2023. Good. So that's the label that I want to put. Now what I want to do is I want to put that into the headers on my counties sheet. So I want to put that starting on row 2. So I'm going to say counties dot cells, row number, always going to row number 1, column number something, its value is going to equal this expression that I just printed out. So instead of just printing it out, what I want to do is I want to put it to a particular place on my counties sheet. So I want it to start in column 4. So when row is 8, when I'm looking at row 8, I want to put the expression based on that row in column 4. When row is 9, I want it to go in column 5. When row is 10, I want it to go in column 6. So what do I put here to tell it to write to the right column? Row minus 4. So when I'm reading from the 4th row, when I'm reading from the 8th row, I want to write to the 4th column. And we're saying we want to put a new value in to the cell that's identified by this expression, and we're going to read it off that same one. That should do it. Variable not defined. It's not counties, it's county. The name of the sheet is counties. Oh, because it worked off the active sheet. Let me delete those. Let's go make this the active sheet because it's reading, it knows what sheet to read because it's the active sheet. I'll run that. And we can see it now has put those, oh, it put it in as Jan space 2008. What did Excel do with that we put in? Because, oh, you mean a date. And so it put it in as the first day of that. I'm okay with that for this example. So we could do something really similar to this to bring in the data, because if you realize it's just the next one over has to do the same kind of thing, flipping it to go one over, but we're out of time. So that's the idea of loops, the three main loops: do loop, for each loop, and we've seen some examples with them. Thanks for coming. Class dismissed. You're too kind. You're too kind. Thank you. Thank you so much.